This section is on Spearman's rank correlation test. This is a nonparametric test used for hypothesis testing the association, or relationship, between the lists of two variables. First, we need to sort the x and y values in order from smallest to largest. Then rank the sorted x and y values, and ties are handled by finding the mean of the ranks for tied values. Next, we reorganize the ranks to correspond with the original order of the x and y values. Then we calculate the differences of the ranks, and then square these differences. Next, we state the claim. Then we state the null and alternative hypotheses. Now the null hypothesis is always the same, that x and y are not associated. But there are three possible alternative hypotheses. So x and y are associated corresponds to a two-tailed test. X and y are negatively associated corresponds to a left-tailed test. And x and y are positively associated corresponds to a right-tailed test. Next, we identify the level of significance, the sample size, and the critical value. Then we calculate the sum of the squares of the differences. Next, we calculate the test statistic, RS, and we use this formula. Then we compare RS with the critical value, and it depends on what type of test it is. So for two-tailed tests, if RS is less than the negative critical value, or RS is greater than the positive critical value, we reject the null hypothesis. For left-tailed tests, if RS is less than the critical value, we reject the null hypothesis. If RS is greater than or equal to the critical value, we fail to reject the null hypothesis. And for right-tailed tests, if RS is greater than the critical value, we reject the null hypothesis. If RS is less than or equal to the critical value, we fail to reject the null hypothesis. Lastly, we write the conclusion. A golf pro wants to learn the relation between the club head speed of a golf club in miles per hour and the distance the ball travels. To run the experiment, she uses a single model of club and ball. The day is also 70 degrees with no wind. The pro recorded the club head speed and measures the distance that the ball travels. The data is listed below. At the 0.05 level of significance, is there enough evidence to support the claim that the club head speed and distance are associated? Use Spearman's rank correlation test. First, we sort the x values. This will be 99, 100, 100, 101, 102, 103, 105, and 105. Next, sort the y values. 257, 258, 263, 264, 266, 274, 275, and 277. Next, we find the rank for the x values. So 99 gets a rank of 1. Because there's a tie in the second and third position, we take the average. So both 100s get a rank of 2.5. 101 gets a rank of 4. 102 gets a rank of 5. 103 has a rank of 6. And because there's a tie for the 7th and 8th rank, we take the average, and both 105s get a rank of 7.5. Now, because the y values have no ties, the ranks are just 1 through 8. Next, we need to reorganize the ranks to correspond with the original order of the x and y values. So 1 is the rank of 99, which is here. 2.5 is the rank of 100, which is here and here. 4 is the rank of 101, which is here. 5 is the rank of 102, which is here. 6 is the rank of 103. And 7.5 is the rank of the 105s, which are here and here. 1 is the rank of 257, which is here. 2 is the rank of 258, which is here. 3 is the rank of 263, which is here. 4 is the rank of 264, which is here. 5 is the rank of 266, which is here. 6 is the rank of 274, which is here. 7 is the rank of 275, which is here. And 8 is the rank of 277, which is here. So now that the ranks are in the original order, we need to subtract the ranks. And we get 1.5, 1, 0, negative 1, negative 0.5, negative 0.5, negative 1, and 0.5. Finally, we square these, and we get 2.25, 1, 0, 1, 0.25, 0.25, 1, and 0.25. The claim is that the club head speed, which is x, and the distance, which is y, are associated. And this is the alternative hypothesis. So this would be a two-tailed test. And the null hypothesis says that x and y are not associated. Alpha is 0.05. N is the sample size, so 8. For the critical value, let's look at the table. So the critical value is going to be plus or minus 0.738. Next, we want to add up the squares of the differences. And this is equal to 6. For the test statistic, we want to use this formula. And it's going to be 1 minus 6 times 6 over 8 times 8 squared minus 1, which is equal to 1 minus 36 over 504. And rounded to 3 places, that is 0.929. So the test statistic is greater than the positive critical value. So we reject the null hypothesis. And the conclusion is, at the 0.05 level of significance, there is enough evidence to support the claim that the club head speed and the distance are associated.